Hello, in this video, I will explain to you on how to solve this problem. So the question is, in the circuit shown in figure E26.23, find the current in the resistor R. So we need to find out the current that passed through this resistor here, R, and then the resistance R, okay, and then the unknown EMF E. Okay, so we need to find out this, and also the current that passed through this resistor here. Okay, maybe let's just follow this. This one goes to the right and this one goes to the left. I think I just want it to be going to the left, right? And you can just assume anything. You can assume to the right or to the left, but when it goes wrong, the direction is wrong, you will get the negative value of the same magnitude, but then that is also not a problem. So let's name this current here as I1. So our goal is to find out, the first one will be I1, okay, and then the second one will be this R here, the value of R, and then the third one will be the EMF of this battery here. Okay, that is for the question A, B, and C. For the question D, if the circuit is broken at point X, what is the current in resistor R? We need a different circuit for that. Okay, so but first we need to find out I1, R, and E here. Okay, let's see this point here or this node here. Okay, let's name this node here as node A. Okay, we can apply the junction rule, not loop rule. Apply the Kirchhoff junction rule. Okay, our friends in electrical engineering usually call it the Kirchhoff's current law. Okay, so what does the Kirchhoff's junction rule say? It is said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, let's see here. What is the current that goes into node A here? This will goes to the right and eventually goes up, right? So it will enter into node A. So this is the first current that goes in, and the value is 6 ampere. So we will have 6 ampere there. Okay, and then is there any other currents that goes in? No, I think all the other currents are going out. So we put the equal sign here and we move to the sum of the current that goes out. So here we will have this current here that goes out from node A, and the value will be 4 ampere. So I will have 4 here, and then plus another current that goes out is this one here. So we will have plus I1 here. Good. Okay, now we can subtract 4 to the both sides here. So I'll have 6 minus 4. That will equal to 4 minus 4 will be 0, right? So I'll have I1 here. So we will have I1 here is equal to 2 ampere. So that is our first goal achieved, which is I1 here. So we will have I1 is 2 ampere, and that is the answer of question A, right? Good. Now what can we do next? We need to do question B and question C, and for that we need to do the loop rule. Okay, let's do exactly that. Maybe I want this here to goes counterclockwise. I just follow the direction of I1 here. Let's name this loop here as loop 1. Okay, and then I just also want to follow this direction here of this 6 ampere current. Okay, so we will have this goes clockwise here also. So we will have this as loop 2. Okay, but to apply the Kirchhoff current law, I mean the Kirchhoff voltage law or the loop rule, we usually place the polarity of the resistor here to to know where the voltage came from, and I mean where the current came from and where the current goes to. So where the current came from, we will have this as positive polarity here, and then where the current goes, see here the arrow goes to the left, so this one will be negative value. Okay, so it is the same for this one. So the positive one is on the right hand side, and here the negative one is on the left hand side. Okay, and here the current goes to the right here, so the positive one will be here and the negative one will be here. Good. And now what can we do from here? I think we can apply the Kirchhoff's loop rule, right? So we need to apply the Kirchhoff loop rule. Apply Kirchhoff loop rule. Okay, and the Kirchhoff loop rule said that the sum of the voltage in a loop will equal to 0. However, we have to be very careful about the sign, right? Okay, now let's start from this battery here. Oh yeah, the battery here, the long one is positive one, so the negative one will be the negative polarity. So this one, the long one is positive and the short one will be negative, right? Let's start from this battery here. Okay, and the loop entering from the negative terminal here, right? It goes counterclockwise, yeah. Okay, it enters from the negative terminal, so I will have negative sign. We have negative sign here, and the value is 28. And then it enters from here, and it enters to the positive terminal. So I will have plus there, but then the value is unknown. We need E there. Okay, so we will have E here. Okay, and then we have this resistor here, and it enters from the negative polarity here, so I will have minus sign. And then we need voltage, so we multiply the current and the resistance. So I will have 4 multiplied by 6. 4 multiplied by 6. Okay, good. And now let's move on to the last resistance here, and it enters from the positive terminal, so we'll have positive sign. So we will have plus here, and then the value of I1 here, we know it, right? We have 2 ampere, so I will have 2 multiplied by the resistance, so I will have R here. R is unknown, and all of that will equal to 0. Okay, let's do some math here. So I have minus 28 plus E, and then minus 24. Okay, and then plus 2R, and that will equal to 0. Good. And now we will have E plus 2R here, and the value is minus 52 right here, but we move it to the right hand side, so we'll have 52 here. Good. And I think nothing that we can do from here. Let's save this as equation number 1. Okay, and we can do another KVL here. I mean the loop rule, yeah, the Kirchhoff voltage law. We usually call it KVL. And in the loop 2. Okay, maybe let's clean up our slide and see what can we do next. Okay, now let's apply another loop rule here. Apply the Kirchhoff's loop rule, but then we need to do it in loop 2. Okay, and then remember the Kirchhoff's loop rule said that the sum of the voltage will equal to 0. Good. Okay, let's see what can we get from here. Let's use another highlighter. Okay, loop 2 here going counterclockwise. Let's start from this battery here. Okay, and it enters from the negative terminal here. So I will have minus sign, okay, negative sign, and the value is E. We have not known E yet, so this value is E, right? Good. And then let's move to another component. We have this 3 ohm resistor, and remember the loop here entering from the positive terminal. So I will have plus sign here, And then what is the voltage? Remember, we have the resistance multiplied by the current. So 3 multiplied by 6. 3 multiplied by 6. And then one more component here, we enter that 6 ohm resistor from the positive terminal. So we'll have positive sign. We'll have plus here. And then the current is 4. And then the resistance is 6. Okay, good. All of that will equal to 0. Okay, so we'll have minus E here, plus 18, and then plus 24. That will equal to 0. Good. So we'll have minus E, and then plus 18 plus 24. I think that will be 42, right? Yeah, 42, I think. 42. And that will equal to 0, or the value of E here, we know it, that it will be 42. And the unit here will be in volt, right? Because all we have in is SI unit, the ohm and ampere. Okay, so we know the value of E here, which is 42 volt. And this is the answer for the question C, right? And we need to plug this into equation 1, okay? So we need to plug this into 1, okay, to get the R here, which is the answer, the question B. Okay, now let's plug in into 1. So I will have E is 42, so we'll have 42 here plus 2R is equal to 52. Good, we can subtract 42 to the both side here. So I will have 2R is equal to 10. Good, but then we can divide both sides by 2. So we'll have R is equal to 5. And the unit will be in ohm. And we will have the answer for R is 5 ohm. Good, and we have achieved the goal of the question A, B, C. However, we still need to answer question D. Okay, maybe let's clean up our slide a bit. Okay, for the question D, we need to redraw the circuit. So if the circuit is broken at point X, so we will not have this component here because we broke this, right? It gets cut out. So we don't have this battery here, and also we don't have this resistance here. Okay, so let's redraw the circuit here. So I will have that 28 volt battery here. Okay, and this one will be positive and negative. And then we will have this R here, but we know the value of R already, which is 5 ohm. Good, and the center component here we don't have it, the middle component, and we only have the bottom one, which is 3 ohm. Okay, so we will have 3 ohm here. Good. And we need to find out the current that pass through the resistor R here. So R is this one, right? Okay, so we can do loop rule here. Okay, loop rule. See, this is our loop. Maybe let's name this loop 3 here. Okay, and because our loop is going counterclockwise, I think it's wise to assume the direction of the current that will be goes there. So the current will be, let's name this as IR here, but then it will also goes here, and that is IR, and it also goes here, which is IR. Okay, now what can we do from here? We do another loop rule. Okay, let's see what can we do here. We need to do the loop rule at loop 3. Okay, the loop rule said that the sum of the voltage in a loop will equal to 0. Okay, but before that, we also need to put the sign to the resistor here, where the current comes from is the plus, and where the current goes to is the -1. And here we also have the +1 here, where the current comes from, and where the current goes to, that will be our minus polarity. Okay, so we start from this 20-volt voltage source, and the loop goes from the negative terminal. So I will have minus here. Okay, so I have minus sign, and the voltage will be 28, right? Okay, now let's move on to this 3 ohm, and the loop enters from the positive terminal. So we'll have plus here, and then we get 3 multiplied by IR to get the voltage. Good. And then we also have this one, and it enters from this positive terminal. So I will have plus 5 IR. Okay, and all of that will equal to 0. And we can simplify this. So I'll have 8 IR. That will equal to 28. So I will have IR here is 28 over 8 here. Or we can divide both sides by 4, right? I will have 7 and I will have 2 ampere, or in decimal, I can have it IR here is equal to 3.5 ampere. Okay, and that is the answer for question D. So we have answered all the question. This is answer for the question A. Here the current in resistor R, and then the resistance R, question B. Question C, the unknown EMF E. So this is question E. And finally, the question D, IR is 3.5 ampere. And I think that's all for this problem. Thank you for watching. See you in the next video. Bye-bye.